In Data Analytics Foundations, you learn that data is any information that can be used to make a decision. So, how can you make decisions based on data in Python? Say you're working with a government agency that performs restaurant inspections. The inspectors take a tour of the restaurant and give it a score from 0 to 100 based on its sanitation. These raw scores are then analyzed to better understand how restaurants are performing overall and to inform customers about health and safety violations. If the score is 90 or above, it's considered an A. The restaurant can display the A grade publicly and is typically inspected less frequently. 80 to 89 is a B. The restaurant must display the B grade and it may be inspected more frequently. 70 to 79 is a C. The restaurant must display the C and will need to take immediate corrective action or face closure. Anything below 70 is considered a failure, which leads to immediate closure. Notice how the different scores branch out into different courses of action. Say you're given a dataset like this one, adapted from one released by the County of Los Angeles, California, USA. You have a column of scores, but they need to be converted to ratings in order to send the correct signage and schedule necessary inspections or closures. This dataset has 67,000 rows, each one representing an inspection. So even though you could do this manually, you certainly wouldn't want to. Let's use a random sample of 5 rows to see how you would go about converting these scores to ratings. Then you can scale up to the entire dataset later. Let's start by making some comparisons. Here are 2 lists representing 2 columns of data, restaurant names and the corresponding scores. So names 0 is Beverly Falafel and score 0 is 96, the score for Beverly Falafel. Having a list of multiple lines like this is completely fine, by the way. You can also store the cutoff score for an A in the variable A, which is 90. The first thing you might ask is the score for Beverly Falafel an A? To do that, print. Label this using the name 0, the first name, got an A, question mark, and then score 0 greater than or equal to A. What do you think should print? Well, the value of score 0 is 96, the value of A is 90, and 96 is in fact greater than 90. So when you run this cell, you get the value true. True is a special type of value that you'll explore more in a moment. Now you can do the same for the other scores. Let's check whether the Melrose Shrimp got an A. So scores 2 greater than or equal to A. The answer is false. The Melrose Shrimp has a score of 79. That's actually a C. Unfortunate. So, greater than or equal to is one comparison operator. How would you check if a restaurant scored less than a 70, which would mean immediate closure? You can ask your LLM to help modify this code. So the LLM says that you can change the condition in the print statement, and it gives you some code to make this new comparison. You can try out that code. The Melrose Shrimp didn't fail. Phew. Notice that the LLM chose a different comparison, less than. Let's check out your options for comparisons in Python. Greater than or equal to is just one of many comparison operators. Comparison operators take in 2 values, one on the left and one on the right, and they answer a question about those values. These questions can only have 2 possible answers, true or false. There's no in between. This type of value, the output, is called a Boolean. Boolean has a fancy name, but it just means a true-false value. It's just another data type in Python, just like int, float, and list. There are 6 comparison operators in Python. First, you have less than or equal to, greater than, and greater than or equal to. These look exactly the same as in spreadsheets and compute a Boolean value, either true or false, based on the inequality. Next, you have equals, which is written with 2 equal signs, and not equals, which is written as exclamation point equals. Why do you think the equality operator has 2 equal signs? That's because the single equals is already taken by the assignment operator, the one used to assign a value to a variable. It's important to remember, if you're checking for equality, always write 2 equal signs. Here's a reminder of the score ranges for different grades on the left, as well as the random sample of restaurant scores on the right. Here are some questions you might have and the inequality that would answer each one. Did Beverly Falafel score an A? You already saw this could be answered with score 0 greater than or equal to 90. Did Modern Eats fail their inspection? In that case, you could use the code scores 3 less than 70. Can you think of another way to answer the same question? That would be scores 3 less than or equal to 69. This inequality answers the exact same question, assuming the scores are of type integer. Notice that if the scores were floats, the second expression wouldn't work, since values like 69.5 would be counted as passing inspection. Did Pasta Roma score exactly 90? You could use the code scores 1 equals 90. Let's put your knowledge to the test. Did Beverly Falafel score 100? The correct answer is score 0 equals 100. Excellent work with comparison and booleans. These operators allow you to make decisions in your code using conditionals. Follow me to the next video to see how.